lately we have been getting a bunch of messages and calls and questions about how to set up custom cam and crank stuff. A lot of people have been building LSs and putting crank triggers on them, and that seems to be the most popular question that we get. So I figured I'd go over some of the different ignition types in Holley software and how to set them up. So if you come in here to your system ICF and then go to ignition parameters, you have some options, right? So a lot of this stuff is already determined or pre-configured for you. But if you decide that you want to do something kind of out of the ordinary, or if you're in a conventional Chevrolet or Ford engine with like a crank trigger and a cam sync, you're going to have to go to custom. But all this stuff is pretty self-explanatory. If you don't know what you have for an LS, if it's a 24X or a 58X, just pop your crank sensor out and look in the engine, and you should be able to tell the difference. There's plenty of good pictures of that online. So we're going to go into custom, and then we click here, configure. So the most common is a 1 pulse per fire. A 1 pulse per fire is a MSD or other 4 magnet crank trigger wheel. And what I mean by 4 magnet is that's for a V8 engine. If it's a 6-cylinder engine, it'd be a 3 magnet. If it's a 4-cylinder engine, it'd be a 2 magnet. So here's our options, right? So we have we can select. We're going to go over the most common ones, right? The most common is in the aftermarket world is a 1 pulse per fire. And I've made other videos on how to set these up, the actual crank trigger. But if we have a 1 pulse per fire, which is a 4 magnet crank trigger, we have the option of setting it to digital rising or digital falling. Digital rising means that the wheel, as it's coming around to its reference angle of 60 degrees, it will see the sensor will see the magnet right before, like on its way up, right? So this the wheel is rotating, and the magnet is approaching the sensor, and that's on the rising edge. The falling edge is when the wheel is rotating and it's getting there to 60 degrees, and it sees the sensor, the magnet and the sensor align, and then when it falls off, that is the falling edge. If you're still using a 2-wire magnetic sensor from MSD or something, you're going to have to change a couple things here. You're going to have to still have a reference angle, but you're going to have a minimum signal voltage, and you're going to have to adjust filtering. I highly recommend just going to a Hall effect sensor, a 3-wire sensor. So that is about the most common one that you wind up using. And again, watch the video on setup on an engine. I've got a few of them on there about how to set up the cam and crank sensors with a 4 magnet or a 12-1. And then if you have same thing for a cam sensor, right? So you have a single pulse cam sensor. A single pulse cam sensor is your MSD drop-in cam sync, or if you have a belt drive with a magnet in the front of it and a sensor, that'd be a single pulse. What that means is it's only seeing 1 pulse per 2 full revolutions, right? So we know that the crank spins at twice the speed of the camshaft, and that's what that means, right? So your crank goes around 2 full revolutions, 720 degrees, and sees the cam sensor only 1 time. And then again, you would set that to digital falling, digital rising, or magnetic. So I prefer digital falling. I prefer to set them all up on digital falling. If we want to do a custom setup, and what that means is we'd do a 1 pulse per fire, right? Like so a lot of the people that reach out to us, they'll buy a MSD crank trigger with a Hall effect sensor for their LS, but they want to continue to use their LS cam sensor. So if it's a 1X LS cam sensor, they select this, and then they select, they don't know what to do from there, right? So there's some really useful information in the help section. So if we go to help and then contents, if we go down here to crank and cam sensor setup, and then go down here to special cases. So we'll come back to this. So here's a 1 pulse per fire, which would be your 4 magnet deal from MSD. Crank trigger with a factory GM LS 1X cam pattern. So if you had a 24X engine and you decided to remove the reluctor from the crank and put a crank trigger on it, these are your instructions, right? So to properly phase the cam trigger location and reference the cylinder number 1 compression stroke, set up the configuration as follows. You have to fudge the firing order. And the reason being is that the 1X cam sensor location is from GM is different than what Holley is looking for. So you'd set up your reference angle between 40 and 60 degrees. And again, if you don't know how to do that, watch the other videos that I've made on how to set these things up, with video on me working on an engine, showing you how to rotate it and where to put the sensor. And then what you'll do is you'll set your cam sensor to single pulse and digital falling. The next one that becomes pretty common is this one right here. So the way that would be done is we would be doing, hold on a second, right here. So 1 pulse per fire with a GM4X cam sensor. So if we change this over here to 4X LS, right, we're still on that same 4 magnet deal. We have different instructions, right? So the GM4X, I don't need to read this for you, right? But this typically will land in the correct area. So you typically don't have to really do much of anything except for set up your 1 pulse per fire crank trigger in the right location. It'll tell you here that the ignition, you do not want to run less than 40 degrees of an ignition reference angle. So again, try to target that 60 degrees, you know what I mean, before top dead center. And then we've got a 58X with a 1X, right? So this is how you would set that up as well. Again, there's a boatload of information in here about how to do these things. So don't forget to look at your help section. Now let's look at, let's say, a 12 minus 1, right? So down here, that's a pretty common one as well. So 12 minus 1 gets set up very similar to the way a 4 magnet works, right? So you need to have a reference angle, but with this, it's actually a TDC tooth number. So if our TDC tooth number is going to dictate our reference angle. So if we have 12 positions here, that means that every single one of these positions is worth 30 degrees. So if we move that TDC tooth number to 2, right, we're going to be right at 60 degrees before top dead center, which is how we set these things up. So you set this thing up at TDC tooth number 2, you can change your digital rising, digital falling. So this little pictogram that's over here is pretty useful. It does not change when you change it from digital rising to digital falling, unfortunately, but this right here, if you look at this, and this goes for the same thing for that 4 magnet setup from like an MSD crank trigger. This would be on the rising edge. So if you look at this, this is your sensor, and this is right before it gets dead center, right? You see how it's a little offset? And then falling would be the crank sensor is kind of down here where it's off the falling edge, right? So, and obviously this is way exaggerated, but this over here would be rising if we had a TDC tooth number of 2, and this would be falling if we had a TDC tooth number of 2. Then you can also put in a timing offset. So instead of messing with your reference angle to get your static timing to match perfectly, you can do a offset, right? So you see we have a timing offset of 10 degrees. Maybe we do a timing offset of minus 10 degrees. You see how it's shifting it, right? Makes sense? So select your TDC tooth number, and then shoot the balancer once you get it fired up, and you can play with a timing offset to get that exactly right. What we mean by that is if we enable a static timing check and our static timing check is 30 degrees, then we shoot the balancer and we have 35 degrees. You're going to have to put a timing offset in here. So next, you'll also have to do the same thing with a cam sensor. So most people that are using a 12 minus 1 are also going to be using a single pulse cam sensor, usually on the outside on like a belt drive or a drop-in from MSD that just kind of takes the place of a distributor. Again, you're going to have to set this up to match your reference angle. So let's look at how that is decided. So if we go to cam sensors here, the cam sync setup when using a 1 pulse per fire crank input. So the easy, if you don't want to do all the math, here's all the math for you, right? But the easy move is if your ignition reference angle is 60, right, before top dead center on the compression stroke, then your cam location has got to be, your cam sensor location has got to be 195 before top dead center on the compression stroke. And then they give you, there's like a little bit of a window here of plus or minus 30 degrees. And that's plus or minus 30 degrees on the crank, not plus or minus 30 degrees at the cam, right? So that's not measuring the movement of the cam sensor, that's measuring the movement of the crank, because we don't have a timing marks on a cam sensor, or on a cam wheel. What else we got? We have, let's look at, and then we can look at the other common one, which is a 36 minus 1. So if you notice, we just populated 36 minus 1, and we've got a whole bunch more teeth. So if we select a TDC tooth number, how would we go about this? We would have to select the TDC tooth number based off of that same target of about 60-degree reference angle, right? So if there's 36 teeth and there's 360 degrees of rotation, you guessed it, each tooth is worth 10 degrees. So if we had a TDC tooth number of 10, that means that our reference angle would be 100 degrees, right? Because we would take that 10 degrees per tooth and multiply it by our TDC tooth number. So we would want a TDC tooth number of about 6. And then again, same thing as a 12 minus 1, we select digital rising, digital falling, and we have a timing offset to be able to move this however we want, right? So do not get in the habit of selecting a TDC tooth number of 6 and then using a timing offset of 10 plus or minus degrees. Move the TDC tooth number. Hopefully that makes sense, because every tooth is worth 10 degrees. There's no reason to be having a timing offset here of 10 degrees or minus 10 degrees, right? Your timing offset should be a maximum of 5, because if you're over 5, then you should be shifting to the next TDC tooth number. Or you should be moving your sensor to line up with the TDC tooth number where you want it when you do a static timing check. I also made a really good in-depth video on static timing checks and how to perform those. Highly recommend watching them. So same thing with the cam sensor. The cam sensors are pretty easy. I'm covering the GM stuff because the Chrysler and the Ford stuff is really not there's really not much to do there, right? So anyway, hopefully this helps. Hopefully this answered some questions for y'all about some of this stuff. We've sold a bunch of our harnesses, and a lot of people have made requests of using, the 12 minus 1 with a Holley Hall effect sensor and a cam sensor from factory GM 4X or whatever it may be. So I figured we would put out a good video on showing how to do all this in your sensor setup. So hopefully it helped. Thanks. See you.